Module 11, problem set 3. Here we'll be finding a Lewis diagram for hydrogen cyanide, HCN. We'll begin by finding our number of valence electrons. Hydrogen in group 1, carbon in group 4, nitrogen in group 5. We'll have a total of 10 valence electrons. We know hydrogen is never going to be the central atom, and given the choice between carbon and nitrogen, we'll go with carbon, given it is less electronegative. We'll attach the adjacent atoms. We'll give everything an octet that needs an octet. Now both the carbon and the nitrogen have their octet. We now need to check to see that we have used an appropriate number of valence electrons in coming up with this Lewis diagram. So we're seeing 8 around that carbon, 10, 12, 14. Right, we're clearly using too many valence electrons in coming up with this Lewis diagram. Recall, every time this case arises, we'll take a lone pair off the central element, a lone pair off the least electronegative of the adjacent elements given the choice. Here we don't really have a choice, they must come from the nitrogen. We will introduce a multiple bond, and we check and recognize, well, we're still using too many valence electrons in coming up with that Lewis diagram. We can only use the 10, so we'll do the same thing. Take a lone pair off the central atom, a lone pair off that adjacent atom. We'll introduce another bond. We're still abiding by the octet rule from the standpoint of the nitrogen. From the standpoint of the carbon, hydrogen has its duet. If we do our electron accounting here, we'll see that we are indeed using 8 plus 2 for 10 valence electrons. This is the correct Lewis diagram for hydrogen cyanide. Okay, let's try another one. Be question 2 from problem set 3. And here we are going to do the amide anion NH2 minus 1. Let's see how many valence electrons we're going to have available. We got nitrogen in group 5. We've got 2 hydrogens plus the 1 more to impart that minus 1 charge. We sum up all of those valence electrons and we see that we have 8. All right, we'll put the nitrogen in the middle. We'll attach those hydrogens. Give everything an octet that needs an octet. Here that nitrogen is going to need its octet of electrons. We now check to see how many valence electrons we've utilized. We've used 8. We had 8. This will be the correct Lewis diagram. For the amide anion, we will simply need to indicate that it is indeed an anion and carries that minus 1 charge. This is the correct Lewis diagram for NH2 minus 1.